Alright, so in this equation, I have x to the power of 2 over 3 is equal to 16. So my only variable in this equation is x. So that's the variable I'm going to be solving for. And now for my solution. I'm going to first start by rewriting my equation down here so I have more space. I have x to the power of 2 over 3 is equal to 16. And what I'm first going to do is take the power of 3 over 2 on both sides. So now I have x to the power of 2 over 3 to the power of 3 over 2 is equal to 16 to the power of 3 over 2. And now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So x to the power of 2 over 3 to the power of 3 over 2 is the same thing as x to the power of 2 over 3 times 3 over 2. And this is equal to 16 to the power of 3 over 2. Now, 2 over 3 and 3 over 2, these two are reciprocals, so they simply cancel out, leaving me with x to the power of 1 is equal to 16 to the power of 3 over 2. And x to the power of 1 is the same thing as x, so I get x is equal to 16 to the power of 3 over 2. However, we're not done yet, because we still have to simplify this. 16 to the power of 3 over 2 is the same thing as 4 squared to the power of 3 over 2. And again, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So these two cancel out, and I get x is equal to 4 to the power of 3, and 4 to the power of 3 is equal to 64. So I get x is equal to 64. Now, I'm going to check to see if this is right. So my original equation was x to the power of 2 over 3 is equal to 16, and x is 64. So I get 64 to the power of 2 over 3 is equal to 16. Now 64 is the same thing as 4 to the power of 3. So now I get 4 to the power of 3 to the power of 2 over 3 is equal to 16. Then these two cancel out, so I get 4 squared is equal to 16, and 4 squared is 16, so I get 16 is equal to 16. Alright, so in this video, I'm going to be teaching you guys how to solve this exponential equation. So we have x to the power of 8 minus 121 is equal to 0. Now, what most people would think to do to solve this equation is add 121 on both sides. So then I would get x to the power of 8 equals 121. And then, since x is to the power of 8, take the 8th root on both sides to get an answer of the 8th root of 121. And this method is actually wrong because there are actually many more solutions than just 2 to this equation. There's many more. So we want to find all of the solutions to this equation. So how are we going to do that? Well, our first step is to rewrite x to the power of 8 as x to the power of 4 times 2. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2. Now I have this minus 121, which we can rewrite as 11 to the power of 2. And the reason we're going to do that is so now we can use an important algebraic property that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x to the power of 4, and b is 11. So I get x to the power of 4 plus 11 times x to the power of 4 minus 11, which is equal to 0. Now, from here, I get two equations. I get x to the power of 4 plus 11 is equal to 0, and x to the power of 4 minus 11 is equal to 0. And we are still not done yet, because to solve this equation, people are going to think, oh, add 11 on both sides and take the fourth root. But we're going to do the same thing we did with our original equation. I'm going to rewrite x to the power of 4 as x to the power of 2 times 2. And now I can rewrite that as x to the power of 2 to the power of 2. And 11, I'm going to rewrite as the square root of 11 squared. So now I can use this property again. So I get x squared plus the square root of 11 times x squared minus the square root of 11 is equal to 0. And again, I get two equations. I get x squared plus the square root of 11 is equal to 0, and x squared minus the square root of 11 is equal to 0. Now, what I can do is, for x squared minus the square root of 11 equals 0, I'm going to add the square root of 11 on both sides. So then these two cancel out, and I get x squared is equal to square root of 11. And now if I take the square root on both sides, square root of x squared is x, and the square root of 11 is the fourth root of 11. This is positive or negative. Now for x squared plus the square root of 11 is equal to 0, I'm going to subtract the square root of 11 on both sides. So I get x squared is equal to negative square root of 11. So now I get the square root of x squared is equal to the square root of negative square root of 11. So the square root of x squared is x. And the square root of the negative square root of 11, I can write this as negative square root of square root of 11. So now this is the same. So now if I take the square root on both sides, I get the square root of x squared is equal to negative square root of 11. Or sorry, the square root of negative square root of 11, which I can rewrite as x is equal to the square root of negative 11 to the power of 1/2, which is equal to negative 11 to the power of 1/2 to the power of 1/2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 1/2 times 1/2 is 1/4. So I get x is equal to negative 11 to the power of 1/4. Now going back here, I have x to the power 4 plus 11 equals 0, so I can subtract 11 on both sides, and I get x to the power 4 equals negative 11. Now I can take the fourth root on both sides, so I get x is equal to the fourth root of negative 11. And this is positive or negative.